Hello again, all you STEM fans out there. Hey, if you're looking for STEM with Mr. C, you're in the right spot. Hey, today we've got a really simple experiment. Doesn't require a lot. It's kind of something we're already familiar with. So we're gonna learn something more about hot and cold, and specifically this experiment is called What a Gas. One, because we're going to be using gas or air, right? Water, kind of water vapor gas. And two, it's a fun phrase from the 50s. If you said, oh, that party, what a gas, that just means it was a lot of fun. You can also use it as like gas as in talking like, see here, yeah, cut the gas there, I'm tired of listening to your gas. Which is, I guess, how they spoke in the 50s. I don't know, it was way before my time. Anyway, for your experiment, really you're gonna just need a bottle, your choice, right? The larger the bottle, the more gas. The smaller the bottle, less gas. I'm using kind of just a 20 ounce, maybe a little bit like a 32 ounce bottle. A little bit of water in here. You don't need a whole lot of water, just a little bit of water. You're gonna need a bowl, and then you're gonna need some really, really hot water, okay? Doesn't need to be boiling, because again, you're gonna be using plastic, but you know, pretty hot water. We're gonna put it in here later. And then you're gonna need a balloon. You're gonna need to stretch out the balloon a little bit. You know, this is one way to do it. And then, just do that a couple times. Woo! Now, and I'm gonna do another experiment, right? I'm gonna use a different bottle, but I'm also gonna use my 91% isopropyl alcohol, just like I did with the making a cloud experiment. If you didn't see that, it's up there. So we made clouds with water vapor, but then to make a really dramatic effect, we used rubbing alcohol, which was super fun. I enjoyed doing it. All right, and then you're gonna need a balloon for that as well. So basically, let's recap. Bottle. Balloon, a little bit of water in here, another bottle if you want, another balloon if you want, rubbing alcohol if you want. You're gonna need a bowl, and then you're gonna need some hot water, and then you're also gonna need a freezer, okay? So if you have a freezer, fantastic. If you don't worry about it. You can also always put a bunch of ice in a bowl and then stick your bottle in there, totally works. Okay, so what we're gonna do, I don't even need to zoom in because we're gonna do everything right here. Really cool, right? So what we're gonna do first is we're gonna take this, and I have a little bit of water. I actually don't need that much water. A little bit of water, and you can just splash it around, okay? And then breathe in your bottle a couple times. So I'm getting all like kind of foggy. Okay, and then just go ahead and put your balloon on, just like that, and make sure. And there we go. There's one. I'm gonna do the same thing with my rubbing alcohol. And just like that. Okay. And I'm gonna shake it up a little bit. There we go. And then same thing, I'm gonna put my balloon on there. I've already, make sure I blow this up. Now, one of the reasons why I do that, one, just because it's fun to do, and I love the sound. It's also, you need to stretch out the balloon a little bit, okay? So if you have a really brand new balloon, you wanna make sure that latex, or whatever you're using, is stretched out enough so it'll actually inflate the balloon. Otherwise, it won't be as a dramatic effect. One more. It's fun. Okay, here we go. And, oh, Adam.
I have something to show you.
AP has something to show me. What do you have to show me?
Oh, so with a balloon, oh, there's one more.
Oh, look at this. Get a cameo by AP. Oh my goodness. Was it my lucky day here? My goodness. Oh, please, come on over.
What?
Yeah, we just did that, so. If you're gonna pop it, I'm not gonna be happy.
Dang it, why doesn't it?
Oh, I know what you mean.
Yeah,
I know what you're trying to make it go. Yeah, so if you want, all right, give me a balloon. All right, impromptu science. Hey, sometimes these are the best science lessons right here. Okay, stop everything. Stop the presses. We're gonna do a little. Okay, so basically just vibrations. So you blow up your balloon, and then take the thing, take the neck, and then. You want to hear the most annoying sound in the world? Here's the most annoying sound in the world.
Oh my God.
Ah. Yes. Yeah. Oh. Oh, good. Can you do that again in this ear because I can still hear it?
Sure.
I'm kidding. All right. Anyway, yeah. All right. So quick science lesson. You do that. You're just restricting the air that comes out of the neck of the balloon, and by pinching it. We're going back to our harmonica lesson, right? Where we talked about vibrations. Remember, sound is nothing more than vibrations. Click up there if you didn't get the harmonica lesson. And so really all we're doing is just stretching the neck out, and then so the air escapes out of the latex, but because we're pinching it, we're forcing the air into in a very narrow channel where then the latex vibrates and you get that wonderful sound. Whew, yeah. Okay, anyway. So we're done here. So what we're gonna do with our balloons, we are gonna go ahead and take these and we're gonna put them in the freezer. So what are you guys waiting for? Let's go. And there's Mr. C's freezer. Oh yes, lots of good things. Yeah, these are actually on sale. Those are really good. If you're a big fan of Baskin Robbins, which I am. So the blue one, remember, the blue one is my rubbing alcohol. I don't really need that.
Oh no!
And then got our water. So water is green, and then rubbing alcohol is blue.
Why is that there?
Why is what there?
That like line, and it gets like way smaller down there.
Because I already experimented with that. Okay. Enough about looking at. Oh, these are really good too. I love those. Yeah, those are really good.
Yeah.
Anyway, yeah, so not only do you get 2 science lessons, you also get to see what's in Mr. C's freezer.
Yeah!
Yeah, a lot of fun. Okay, hey, so you're gonna leave it in there for about an hour, right? You get 30 minutes is fine, but if you want really dramatic effects, in an hour, okay? So once you do that, we're gonna come back and we're gonna see what happens. So don't go anywhere, because you gotta watch your freezer, okay? Don't leave it unattended. Don't leave a science experiment unattended. Okay, we'll be right back. All right, what's up everybody? It's been about an hour and we're gonna check on our balloons. So we're gonna do them one at a time. First one I'm gonna do is the water. So let's go ahead and take a little peek in our freezer. There we are. And before we take them out, let's look at some observations here, right? One, yes, it's cold. That's an observation. But look at my bottle, right? You see how it's collapsed in. I didn't put it in there like that. So that's interesting. And look at the balloon as well. It's all kind of just, it's all like someone just took a vacuum and went. So what we're gonna do, I already have, I'm gonna take this out. I'm gonna leave the alcohol bottle in there. All right, and then we're gonna go ahead and nice little top-down view here. There we go. All right, and then I've got my hot water. Yep, that's hot. And then I'm just gonna hold this and watch what happens. And gotta hold it, otherwise it's gonna go. And there we go, instantly, pretty much. And something else you can do, go ahead and touch that balloon. That balloon is very cold, right? It's a very cold balloon, and you just hold it right here. We'll see how long that expands, because as we learned, right, something that is cold, the molecules are moving around a lot slower. Even cold gas, right, it moves around very slowly. Hot gas, when we put our cold bottle with our cold balloon in the hot water, instantly, well, almost instantly, that cold gas gets turned into hot gas, which then it has nowhere to go, so it's gonna come up through this balloon. And go and squeeze that. I mean, that's a good amount of pressure right there. Now, if you did this with a larger bottle, you're generally going to see a lot more dramatic of a result. All right, I think that's about all we're going to get, and I feel the balloon. The balloon's still cold, so it'll take a minute, right? We could leave it on here. I don't think it's going to get any bigger, but there you go, the power of gas, right? Cold gas turning into hot gas, expands. It doesn't really have anywhere to go but through our nice flexible balloon. I'm gonna go ahead and take that out. Beautiful. I'm gonna dump this hot water. Do I still have enough? I got enough hot water. Oh, that is plenty hot. Woo, nice and hot. All right, I'm gonna grab the alcohol bottle, and we can see the same thing has happened, right? Kind of collapsed in on itself. So we're gonna hold it nice and tight, pop it in, and I'm not doing anything, folks. I'm just holding the bottle here. And so we don't get as much of a reaction. I mean, it still expands, but there really wasn't a lot of alcohol vapor in there, and you know, it's just not that cool of a reaction. But you still, there we go, we'll inflate again. Getting there, come on, you can do it. No, that's all we're gonna get. And that's okay, right? The water vapor tends to work a lot better, right? Which is interesting because our cloud experiment, the alcohol worked a lot better than the water did. And then I take it out and we'll watch the balloon go bloop. And then we put it back in and the balloon goes bloop. And then we take it out and then it goes and then we put it in. So all we're doing is we're just expanding the gas here. That's all we're doing. We can do this for a little bit longer. But yeah, because we're just basically superheating this rubbing alcohol that's in there. We can even spread it up a little bit. And that's about all we're gonna get. We get a little more. And there we go. All right, so that is our experiment. I'm gonna come down here with you guys. Hey, so that's our experiment, What a Gas. One, because it is actually kind of fun, right? Blowing, taking a balloon, putting some water in a, drink bottle, put it in the freezer, take it out an hour later, watch what happens, put it in some hot water. So it's interesting, right? The science behind that. We just kind of talk through it, but things that are cold take up a lot less room because they're moving a lot slower. And you can see this with water, right? You have liquid water, you have ice as a solid, and then you have water vapor as a gas. Well, a gas takes up more space than a liquid does, and a liquid takes up more space than a solid does. So as we go from gas to liquid to solid, it takes up less and less room because the molecules are getting tighter and tighter and tighter together. So when you expand that, when you go from even a cold gas to a hot gas, those molecules are bouncing around and they need to go somewhere, and that's why the balloon inflates. So you can try this with water, try it with different liquids if you want. I tried it with rubbing alcohol, not really sure what else you'd want to try it with. Maybe some salt water, see what that would do. Probably gonna get the same result, but hey, STEM is all about experimenting. It's all about trying different things, taking what I did and seeing what happens with it. So hey, thanks for joining me with this. It's kind of a quick experiment, but a lot of fun. What a gas. Not only is it a lot of fun, but water vapor, what a gas it is. All right, see you guys.